All right, so this is the key to the quiz. And in number one, I know you can't see this function right here, at least the coordinates, the x values and the y values here. But we'll go over that. Um, but you want to find the domain of this function. I remember when finding the domain of the function, the domain is the set of x coordinates. So as we determine the domain, it's always a good idea to go along the x-axis from left to right. So remember, you're going to indicate the domain and range as an interval. So you're going to go from smallest to largest. So notice that on this function, there's an arrow on this side, and there's an open circle on the left side. So that's not an arrow, that's an open circle, and this is an arrow. But as I go from left to right, notice I start touching the graph when I get to this point here. Even though it's an open circle, we're still going to indicate that's where I touched the graph, right here, at the x value, and this is -6 right here. So this right here is the point, -6, -7. So 6 to the left, 7 down. Now keep in mind though that that's an open circle, so that's not part of the graph, but we still indicate that information when discussing information about the domain and range and information about the graph, the function. So I'm going to go from -6, from x equal -6 all the way. So if you look at every point on this graph, if you look at the x-coordinates, every point of the graph, it's going to be from -6 all the way to, and just keeps on going. See this arrow just indicated keeps on going. So all the way to infinity. So those x values that you see here, those x values are going to be any number in the interval from -6 all the way to infinity. All right, so that is going to be my domain. Now, when talking about domain and range, remember we also discussed whether we need parentheses or brackets. The fact that this is an open circle, see -6, -7 is not a point of the graph. So I have to indicate that as an open circle here. So we're going to say -6 all the way to infinity. So that's your domain. The range is a set of y coordinates. So notice I'm going along the y-axis from bottom up, because whenever we talk about intervals, we indicate from smallest to largest. Now, as we go along here, you'll see why it was important that you indicate the coordinates of this open circle right here. So when I go from bottom up, notice I start touching a graph at this open circle. Just like when I talked about the domain, I started touching the graph at this open circle as well, right? So when I go from bottom up, same thing. I start touching the graph of this function at this open circle. But remember that the range is a set of y coordinates. So instead of talking about those x values that we did here for the domain, I need to talk about the y coordinates of these points here. The y coordinates of these points. So notice that when I start touching the graph, this y coordinate, and you can't see it very well, but that's -7. That's -7. -1, -2, -3, -4, -5, -6, -7. Okay, so I'm going from -7, and notice all these points. Now this time we're talking about the y coordinates. So don't look at the x coordinates, we're looking at the y coordinates. So every point on this graph, the y coordinates are going to be anywhere from -7 all the way to infinity. Because remember this arrow right here. Okay, it doesn't stop, it just keeps on going. So that's your range. So it'll be -7, parentheses -7 to infinity. Okay? And remember, whenever we talk about infinity, negative infinity, it's always an open circle. All right? Now, letter C. You want to find f of 6. So remember, f of 6 means what is the y value when x is 6? Remember, this means the same thing as f of x, so x is 6 here. So we go along the x-axis and we locate where 6 is. Well, 6 is right here, right, on the x-axis. So we locate the point associated with it. So the point associated with it is this. It's a good idea to label that point. So when I label that point, I get 6, 3. And so therefore the y value, remember this means what's the y value when x is 6? Well, the y value when x is 6, so here's x equals 6, my y value is 3. So you're going to put 3 here. Okay? F of 0, so same thing. So the question is, what's the y value when x is 0? So this is x, so x is 0. So x is 0 here, right? So I'll locate the point that's associated with x equals 0. That's this point here. So when I label that point, the x coordinate is 0 and the y coordinate is negative 4. So the answer, f of 0. So what is the y value when x is 0? The y value is negative 4. So that's what you put in the blank. Okay, number 2 discusses a piecewise function, and all you needed to do here was to evaluate those piecewise functions, this piecewise function at these values of x. All right, so remember f of x is equal to 2x minus 3 if your domain is greater than 4, if your x value is greater than 4. And then if the x value is less than or equal to 4, then you're going to use f of x equals 3x plus 4. So in this case, I want to find f of 7. So when finding f of 7, I got to make sure I use the correct part of this function. So my x value is 7, so you got to locate which of these is 7 in this domain. So is 7 less than or equal to 4? The answer is no, right? 7 is not less than 4, but 7 is greater than 4, so you're going to use this one. So you're going to use 2x minus 3. So in place of x, I'm going to substitute 7 now. So 2 times 7 minus 3. 2 times 7 is 14. 14 minus 3 is 11. So I get 11 here. Then we do the same thing with f of 4. So f of 4 means what is the y value when x is 4? So I got to locate which one I'm going to use. So this says x equal 4. So you can't use this one because 4 is not greater than 4, right? But 4 does equal 4, so this is one you're going to use. So for letter B, you're going to use 3x plus 4. And in place of x, you're going to substitute 4. So you get 3 times 4 plus 4. So that's 12 plus 4, which is 16. All right. And then f of negative 3. So again, I have to determine which of these I'm going to use. Well, x in this case is negative 3, so we all know that negative 3 is less than or equal to 4, so I'm going to use 3x plus 4. So let's use 3x plus 4, and so I get 3 times negative 3 plus 4, so that's negative 9 plus 4, which is negative 5. Alright, so that was the answer there. Now in number 3, you're given this quadratic function, and you want to find the average rate of change on this interval. And then it did say show work. Alright, so to find the average rate of change of this function, it's kind of like the idea of that slope, change in y over change in x. So the average rate of change is going to equal, now in the numerator, you're going to subtract the y coordinates, and in the denominator, you're going to subtract the x coordinates. So the idea of rise over run, the idea of slope. And in the x coordinates, that's going to be these, in the interval from negative 2 to 3. So in the interval from x equal negative 2 to x equal 3, how's my function changing? What is the average rate of change? It does not matter whether you say negative 2 subtract 3 or 3 subtract negative 2. It does not matter. You'll see you'll get the same thing. So you can say 3 subtract negative 2 or negative 2 subtract 3. It does not matter. Some of you did this, some of you did that. Now remember, those are your x coordinates. Now you have to find your y coordinates. So to find the y coordinates, remember this is g of x, same thing as y. To find the y coordinates, you're going to substitute in place of x these values here that you have. But just like slope, remember the order matters. So if you put 3 here, then you have to put g of 3 first in the numerator, and then subtract, and then since you have negative 2 listed second, then you're going to say g of negative 2. Over here, since I have negative 2 first, whoever did this one's going to say g of negative 2, subtract, and then g of 3. And then it's just a matter of you finding g of 3 and a matter of you finding g of negative 2, and then you do the rest. So g of 3, remember, to find g of 3, you go to your function g, and wherever you see the variable x, you substitute 3. So I get 3 squared plus 3 times 3 plus 1. So 3 squared is 9, 3 times 3 is 9, and then plus 1. So I get 18 plus 1, which is 19. G of negative 2, we'll go ahead and do that here. G of negative 2 is going to equal, and then in place of x, you substitute negative 2 this time. But remember, be careful, x is negative 2, so you need to put that in parentheses. So I get negative 2 squared plus 3 times negative 2 plus 1. Negative 2 squared is 4. 3 times negative 2 is a negative 6 plus 1. 4 minus 6 is negative 2. Negative 2 plus 1 is a negative 1, right? So you get negative 1. All right, so now we're going to figure this out here. So g of 3 is 19. Subtract g of negative 2, which is negative 1, divided by 3, subtract negative 2, right? Over here, the person would have said g of negative 2, which is negative 1, subtract g of 3, which is 19, divided by negative 2 minus 3. All right, well, 19 subtract negative 1 is 20, 19 plus 1. 3 subtract negative 2 is 5, so you get 20 over 5, which is 4 divided by 1. I did tell you to write as a fraction, so leave it as a fraction. Don't write as 4. I did indicate state as a fraction, so you would know that the average rate of change is for each change in, so for each 1 unit change in x coordinate, my y value changes by 4. So that's why I asked you to leave as a fraction, so you'll have a better sense of what this represents. So for one change in horizontal distance, my vertical distance changes 4 units, and it goes up 4 units. All right, so kind of like this. All right, and then over here, if you'd done that one, you would have said negative 20 divided by negative 5, which is the same thing, 4 divided by 1. All right, so it did not matter which approach you took for here. Notice you get the same answer. All right. Okay, so that is the key to this worksheet or this quiz.